Bismillahirrahmanirrahim. As we all know that we discussed the chapter in the class was based on organizational design, competencies, and technology. Uh, the technology is basically when we talk about the technology, so we say that the technology is the combination of skills, knowledge, abilities, techniques, materials, um, computers, tools, and other equipment that people use to convert uh, um, or change raw materials, problems, and new ideas into valuable goods and services. Here we say that we can talk about if we think about the organization, so we likely to think of it in terms of what it does. And when we think of manufacturing organizations like Ford, some others organization as places where people use their skills in combination with machineries and equipment to assemble inputs into the you can say that into the appliances like cars and other finished good products. We view service organizations like, for example, the hospitals and banks and places where people apply their skills in combination with machinery or equipment to make sick people well or to facilitate customers' financial transactions. So this is basically what I'm saying is what we are linking it is basically the combination of skills, knowledge, and abilities, and then these things are techniques or materials we can say that, or you can say machines or computers or tools we can say that these combinedly convert or change the raw materials and problems into ideas that what we say that are goods and services. Like in for the earlier example of the hospitals, we talk about the service. And when we talk about a cars or we talk about Ford or the others international brands, we talk about goods. When people at Ford, the Mayo Clinic, the H&R Block, and Google use their skills, knowledge, machines, materials, whatever this we say that to produce a finished car, a cured patient, a completed tax return, or a new online application, they are using technology to bring about change to something to add value to it. Inside an organization, technology exists at three levels: individuals, functional, or we can say that departmental, or so then we in inside an organization, technology exists at three level: individual, functional, or departmental, and organizational. At the individual level, technology is the personal skills, knowledge, and competencies that individual women and men possess. So this is basically so in inside an organization, technology exists at three levels, as we already explained that individual, functional, or departmental. So the individual, when we're talking about individual, so the individual is the personal skills, knowledge, and competencies that individual women and men possess. At functional or departmental, the procedures and techniques that groups work out to perform their work create competencies that constitute technology. So here, when we're talking about department and functions, so we talk about that the procedures are the techniques that a particular group is performed for to create the competencies. So for individuals, we say that we have own individual skills and knowledge and the experience we have. Then the other thing is the way an organization converts inputs into outputs is often used to characterize technology at the organizational level. Mass production is the organizational technology based on competencies in using a standardized uh, progressive assembly process to manufacture goods. And then the other thing is the crafts work is the technology that involves group of skilled worker who interact closely to produce custom designed products. So these are the crafts worker, you can say that. The difference between these two forms of technology is clearly illustrated in organizational, you can say that, in the organizational technology, in the organizational, we can say that insight are the others role model. For example, we can talk about the progressive manufacture at Ford. They have started their operation in 1913 with the initially the car structure, the initially the manufacturing process was totally different from nowadays. The workers work together, they modify, and the some of the parts were misaligned, but later on they work together and to solve the problems. And they have set some follow specifications and create small batches of a range of products in the Ford manufacturing. Uh, um, and then they get then on a later period, then the craftsmen's the workers has to realize they're on the skills and expertise. So they mostly work on their skills, and then they work on their competencies and enhance the competencies. So with these things, they work to deliver a good thing. They work together for a good specific sequence of work. The individual tasks were broken down into a technology. So nowadays, with what we are seeing it and the results, what we are working is a far different. What they are working is a far different from the earlier days. And then technology and organizational effectiveness is relate with the three things: the input process, the conversion process, the output process. These are the basically we say it is the relate with the uh, in the context of the effective. So the work enters through the input process, sorry, and then the work leaves is to in the output process. So at the input stage, we talk about technology, skills, procedures, techniques, and competencies. Uh, Allows each organization functions to handle relationships with outside stakeholders so that the organization can effectively manage its specific environment. The human resource functions, for example, has techniques such as interviewing procedures and psychological testing that it uses to recruit and select qualified employees. The material function has developed competencies in dealing with input suppliers for negotiating favorable contract terms and for obtaining low cost, high quality component parts. The finance department has techniques for obtaining capital at a cost favorable to the company. So these are the process we already have familiar with it, and we already discussed in the class in the previous classes as well. If there is any questions, you can ask directly through the WhatsApp group, and so we can discuss if whatever the confusion you people have. Keep in mind one thing is that when we are discussing in these two online classes, I will take one of the additional class to cover up the deficiencies of the contact hours. So I will cover to cover the deficiency as well. Okay. Then the other thing is that when we're talking about technology, so you take the example of the organization input, conversion, and output processes and an important source of a company's competitive advantage. For example, we can say that if we can say the question is, why is Microsoft the most a successful software company? Why is Toyota the highest quality car maker? Why is McDonald's the most efficient fast food company? Why does Walmart consistently outperform Kmart and the others streamlined businesses in this area? Each of these organizations excels in the development, management, and use of technology to create competencies that led to higher value for stakeholders. So when we talk about three principal approaches to measuring and increasing the organizational effectiveness, is the organizations taking external resource approach, use technology to increase its ability to manage and control external stakeholders. Others than with what we say is the we talk about is that when we say that the conversion stage technology, a combination of machines, techniques, and work procedures, transforms inputs to the outputs. The best technology allow an organizations to add the most value to its inputs at the least cost of organizational resources. So organizations often try to improve the efficiency of their conversion processes, and they can improve it by training employees in new time management techniques, uh, and by allowing employees to devise better ways of performing their jobs. At the output stage, technology allows an organizations to effectively dispose of finished goods and services to external stakeholders. To be effective, an organization must possess competencies in testing the quality of the finished product, in selling and marketing the product, and in managing after sales service to the customers. So these are some of the points when we is discussing it, and when we are talking about, as we all know that organization use technology. What is the purpose to use technology is to become more efficient, more innovative, and the better able to meet the needs and desires of stakeholders. So each department or function in an organization is responsible for building the competencies and developing technology that allows it to make a positive contributions to organizational performance. When an organization has a technology, so we can say that enables it to create value. It needs a structure that maximizes the effectiveness of the technology. We can say that just an environmental characteristics require organizations to make certain organizational design choices. So do the characteristics of different technologies affect an organization's choice of structures. So these are the things we say it in terms of these matters. So now when we talking about the other things, so the theories of the technology, another thing is also very much relate, are also very much played role in terms of the technology, in terms of the, you can say that, resources, in terms of the structure, in terms of the department technology, in terms of the organizational designs, we can say that. So I will make it a very clear or very simple for you that all theories which is related with the organizations, for example, we can say that the context of the complementary, the context of the characteristics. So the ways department and organization technologies work and affect organizational design. So number one thing is, when we're talking about these kind of the technology, is that choose the technology that will most effectively transform inputs into outputs. Second thing is, a design a structure that allows the organization to operate the technology effectively. Thus, it is important for these managers to understand the concept of technical complexity, the underlying differences between routine and complex tasks, and the concept of the task interdependence. So these are the major concepts when we related, when we linked it with the with different elements, or we can say that these are the things which I already explained to you, that why these are the things are very much. Now come to the theories which I pointed out. Uh, the number one thing is the technical complexity. The theory of John Woodward is the some kinds of technology are more complex and difficult to control than others because some are more difficult to program than others. The technology is set to be programmed when rules and SOPs for converting into outputs can be specified in advance so that tasks can be standardized and the work process be made predictable. McDonald's uses a highly programmed technology to produce hamburgers, and so does Ford to produce its vehicle, and they do so to control the quality of their outputs. Hamburgers are cars. The most difficult is to specify the process of converting inputs into outputs. The more difficult is to control the production process and make it predictable. Now, here is the thing is when we conclude it or when we relate it. So the first thing is when we is talk about is the program technology, and the other thing is the technical complexity. You need to understand what is program technology. So I can explain it to you and then we will discuss it. The technology in which procedures for converting an output, inputs and output can be specified in advance so that tasks can be standardized and the work process can be made predictable. This is known as a program technology. Technical complexity is a measure of the extent to which a production process can be programmed so that it can be controlled and made predictable. It's basically you consider you're talking about the SOPs. In the program technology, you are talking about rules. In the technical complexity, you're more talking about a production process. You're more talking about the SOPs. So these are some of the things which we need to understand. Um, in the technical complexity, we have according to one of the researcher, John Woodward, the technical complexity of a production process is the extent to which it can be programmed so it can be controlled and made predictable. It is the important dimension that differentiates technology. High technical complexity exists when conversion processes can be programmed in advance and fully automated. With full automation, work activities and the outputs that result from them are standardized and can be predicted accurately. Low technical complexity exists when conversion processes depends primarily on people and their skills and knowledge and not on machines. With increased human involvement and less reliance on machines, work activities cannot be programmed in advance and results depend on the skills of the people involved. This when we're talking about human involvement, so we cannot depend on the machines. The more worked, the more things were dependent on the skills of the people. How much your people are skilled, how much they have the understandings, how much they have the involvement. So in this things, we can say that the production services, we can say that typically that relies on the human. So when we're talking about we more rely on the human, so we can think about that the people need to work in that particularly area or in that particularly production process. So these are the things which is differentiated from the machineries to the human skills. Other things that they identified is John Woodward identifies 10 levels of technical complexity, which she associated with three types of production technology. One is the small batch and unit technology. As you remember it in the last class, I showed a video related with a small batch and a unit technology, and also we discussed some large batch and mass production already in the class. We last class we discussed this thing. And the third thing is the continuous process technology. A small batch and unit technology is organizations that imply small batch and unit technology make one kind of a customized product or a small quantity of products. Example of such organization include a furniture maker that constructs furniture customized to the needs and taste of specific clients, a printer that supplies the engraved wedding invitations that a particular couple desires, and a team of surgeons who work in specialized hospitals that provide a specific set of services such as eye and knee surgery. If we see the example or the context of the Pakistan, so herein we're talking about surgery or the surgery equipments. So few of the people know about it. In Pakistan, the Sialkot is one of the area, is one of the place where the surgery equipments are has a large demand and they have manufactured. The Sialkot is basically one of the place where the people are working in a small batches, and as well as they producing large batch manufacturing, and they have a mass production with respect to the surgery, and as well as if we take the example of the football, so there is a large market worked for the football manufacturing, the football making. Then they have the control, they have the work, and they provide these products in the large rest of the world, and they exports these products. So Sialkot is one of the area they have a lot of export in terms of so many products. Two of the I shared with you. So the surgeries and these are things. So they there is a need to work on the batch wise, and there is a need to produce products as per the demands, and you have to see it that what is the capacity of your machineries, your products, and then you have to produce it accordingly. John would identify 10 levels of the what are the 10 levels is the flexibility of the small batch technology gives an organization the capacity to produce a wide range of products that can be customized for individual customers. For example, high fashion designers and makers of products like fine perfume, custom built cars, and specialized furniture use small batch technology. Small batch technology allows a custom furniture maker, for example, to satisfy the customer's request for a certain style of table made from a certain kind of wood. Krispy Kreme constantly refine its production system to improve the efficiency of its small batch operations. This was a video we discussed in the class. So if the people who do not have the access or do not have seen the video, just search on the YouTube Krispy Kreme production unit. So you will get the video and you will see that how they produce or how they work on their donut machines to include a high tech extruded that use air pressure, and this force donut dough into a row after row of rings or shells. Employees used to have adjust our air pressure manually. So we discuss it. If you have questions, so we can discuss it. Large batch and mass production to increase control over the work process and make it predictable. Organizations try to increase the manufacturing process, and then we see it. They try to increase the level of technical complexity and increase their efficiency. Organizations that imply large batch or mass production technology. So these are the examples of the cars, razors, blades, aluminum canes, soft drinks. Examples of such is Ford, Gillette, Crown Core, and Seal and Coca-Cola. These are the large batch and mass production technology machines control the work process. In the previous, we talk about the 10 basically we talk about 10 levels of technical complexity. What are that 10 levels? Is basically number one is the production of simple units to customers order. Number one is the production of simple units to customers order. Second thing is the production of technically complex units. Third is fabrication of large equipment in stages. Fourth is the production of small batches. Fifth is the production of components in large batches, subsequently assembled the diversely. Six is the production of large batches assembly in line type. Seven is the mass production. Eight is the process production combined with the preparation of a uh, uh, of a product for sale by large batch or mass production methods. 9 is the process production of chemicals in batches. The tenth is the continuous flow production of liquids, gases, and solid shapes. So these are the things. Now, the first, you can say that the first 5 points is covered small batch and unit production. The second one is when we're talking about 6th, 7th, and 8th points is covered large batch and mass production. Group 2. First 5 points covered group 1, which is known as small batch and unit production. Second group is large batch and mass production. This is group number 2. Third is, we can say that the continuous process production, which is related with the 9th and 10th point, which is known as process production of chemicals in batches. 10 is continuous flow production of liquids, gases, and the solid shapes. So these are the elements which is related with the technical complexity and as well as the 10 points which earlier discussed with you people. Now moving to further is the other elements is related with the other. The control provided by large batch and mass production technology allow in organizations to save money on production and charge a low price for its products, we can say that. And then furthermore is the other thing is that we say it is the continuous process technology. Organizations that imply continuous process technology include companies that make oil-based products and chemicals such as Exxon, DuPont, and Dow, and brewing companies such as the Butch and the Miller. In continuous process production, the conversion process is almost entirely automated and mechanized. Employees generally are not directly involved. Their role is basically. Furthermore, is the technical complexity and organizational structure. One of the Woodward's goal in classifying technologies according to their technical complexity was to discover whether an organization's technology affected design of its structure. Specifically, she wanted to see whether effective organization had structure that meet the needs of their technology. A comparison of structural characteristics of organization pursuing each of three types of technology revealed systematic differences in the technology structure relationship. Organization with a small batch technology typically has 3 levels in their hierarchy. Organizations with mass production technology has 4 levels. An organization with continuous process technology has 6 levels. The Woodward's results strongly suggest that technology is the main factor that determines the design of the organization structure. If a company uses mass production technology, for example, then it should have a mechanistic structure with 6 levels in the hierarchy, a span of control of 1 to 48, and so on to be effective. The argument that technology determines structure is known as the technological imperative. The other thing is the task variability and task analyzability. These are very important points you need to understand. Task variability is the number of exceptions, new and unexpected situations that a person encounter while performing a task. This is a task variability. Exceptions may occur at the input, conversion, or output stage. Okay. Then the task variability is high when a person can expect to encounter many new situations. जब न्यू सिचुएशंस होंगी तो टास्क वेरिएबिलिटी obviously ज़्यादा होंगी. Our problems in performing his or her task in an hospital operating room during the course of surgery, for example, there is much opportunity for unexpected problems to develop. I think this example is very much to clear this task variability. The patient's conditions may be more serious than the doctors thought it was, and the surgeon may make a mistake no matter what happens. The surgeon and the operating team must have the capacity to adjust quickly to new situations as they occur. Similarly, great variability is the quality of a raw material, makes it specifically difficult to manage and maintain consistent quality during the conversion stage. If you do not have a raw material and if you do not manage it properly, so then you can face the problem in the conversion stage. Routine task and complex task, the theory of Charles Perrow is the task variability is low when a task is highly standardized or repetitious. So as a worker encounters the same situations time and time again. In fast food restaurant, for example, the number of exceptions to a given risk task is limited because they're doing it again and again. So they have the understandable things. Each customer places a different order, but all customers must choose from the same limited menu. So employees rarely confront unexpected situations. They do not face any kind of things. In other terms, we can say that this kind of a thing is whosoever is has the idea of these things, they basically add the innovations in the organization process. In fact, the menu in a fast food restaurant designed for low task variability, which keeps cost down and efficiency up. Task analyzability is the degree to which search and information gathering activity is required to solve a problem. The more analyzable a task, the less search activity is needed. Such tasks are routine because the information and procedures needed to complete it have been discovered, rules have been worked out and formalized, and the way to perform a task can be programmed in advance. For example, although a customer may select thousands of combinations of food from a menu at a fast food restaurant, the order taker's task of fulfilling each customer's order is relatively easy. The problem of combining food in a bag is easily analyzable. The order taker picks up the drink and puts it in the bag, then add the fries, burger, and so on, folds down the top of the bag and hands the bag to the customer. Little thought or judgment is needed to complete an order. This is last paragraph is basically related or a true example of a task analyzability. Four types of technology is the routine manufacturing. Routine manufacturing is characterized by low task variability and high task analyzability. Few exceptions are encountered in the work process, and when an exception does occur, little search behavior is required to deal with it. Mass production is representative of routine technology. Craft work with the craft technology, task variability is low. Only a narrow range of exceptions is work in the exception is work in the technology employee in an organization is related with the kind of technology need to adapt existing procedures to new situations and find new techniques to handle existing problems more effectively. And the last one is when the engineering production with engineering production technology. The other thing is the procedures are often codified and technical formulas, tables, or manuals. Solving a problem is often a matter of identifying and applying the right technique. Is when we relate is the last point is we discuss is the non-routine research. Non-routine research technology is characterized by high task variability and low task analyzability and is the most complex and least routine of the four technologies, which Parrow's classifications are according to task are more complex because not only is the number of unexpected situation is large, but such activity is high. Each new situations create a need to expend resources to deal with it. So these are the four technologies are the other part of the lecture related. This covers our this part of the lecture. Later on, I will discuss the same things with you and we will discuss the others part as well.